Hello, thank you, and welcome. This talk will be a little bit different than it was planned. I'm going to present the Blackbird render, and initially the plan was to present this as the work and as a representative of tangent animation. Now, as some of you may have heard, tangent animation about 48 hours ago closed its doors, unfortunately, which means I had to somehow redo my presentation, and it is not as well rehearsed as it could be or should be. I still hope that I can present something that is of interest to you and that I think applies to the open source world. So this slide is probably not as important as it was before. Tangent Animation slightly is, an animation studio with offices in Winnipeg and Toronto. And it had delivered 2 feature films called Aussie and Next Gen. And moving on to the actual content, what was going to present, which is Blackbird. Blackbird, in a nutshell, so this is the takeaway from this presentation as was intended. It is or was the in-house production render that we built at Tangent Animation. It is based on a fork of the Blender render engine called Cycles, which is a physically based path tracer. Our version called Blackbird was built as a USD Hydra Delegate, which meant that you could use it in many other applications outside of Blender. And we built it to be released under the Apache license as open source. Now going back a bit in history, before Blackbird, how we were using the Cycles render, what we were doing with it, and what led to development of Blackbird. So before, we produced 2 movies, feature films called Aussie and Next Gen. Next Gen is released pretty much internationally on Netflix. If you haven't seen it, I recommend watching it. And this was produced using Blender as the main production tool, which meant that all lighting and rendering was done using the Cycles render engine. We were using some of Houdini and Substance Painter and similar tools for additional tasks, but the main core and part of the pipeline was built in Blender. Now, Blender being open source allowed us to adapt it to our needs. Initially, when we started working on Next Gen, there were a few roadblocks in Cycles and Blender that we just needed to overcome in order to deliver what we wanted to deliver. A number of these improvements were pushed upstream back towards the Blender Foundation and are now part of the official Blender distributions. So for handling massive scenes and motion blur, we added support for the Embry open source library. We implemented the CryptoMath standard for compositing. And pretty much as soon as Open Image Denoise came out from Intel, we also jumped on it, implemented it, and it happened really quickly. It was fairly easy. And that also made its way into the main Blender distribution. Now, you would think that using pretty much Blender at its core as a single application through almost our departments would make for a fairly simple pipeline that we would keep all of the workflow, all the artists would work inside Blender. We would use Blender files as description for a scene, and we would just render out using Cycles. So that is the ideal world that you would think that this could look like, should look like. In reality, it was not that easy. There are just some things where other programs are better than Blender. Let's not sugarcoat this. And so Houdini was being used for certain effects in the show. And getting assets from Houdini to Blender meant we had to go through Alembic, OpenVDB, or other file formats, and then import those into Blender, where they would end up inside blend files, and then to be rendered inside Cycles in our own version, which again ran tight, built into Blender. In addition, whenever we wanted to incorporate new changes from Blender, or actually push our changes back, those were separate sync steps we also had to do. And this would need to be something to be done carefully, especially when some of the render changes were tied to application changes. Since all of our files and assets were in the native Blender file format, we couldn't just go back and forth between different Blender versions and use in-house, use external, without risking actually breaking files and making incompatibilities. An additional problem that we had there is that the Houdini artists or people working in pretty much any other application in Blender did not have access to the render engine as we used it. So some of the effects artists had the valid complaint that they could not actually see how the things would turn out in the end until they actually went through the pipeline and turned it into a Blender scene to actually run it inside cycles. Because the render engines they had available in Houdini would not necessarily give them the same result as would actually end up in the film. And to complicate this even more, the Blender Foundation is actually pretty quick, and the open source community at moving Blender forward, which is a good thing. So there will be new features and new bug fixes coming out almost constantly. Meanwhile, trying to build on a more stable version, we cannot just constantly upgrade versions. This would need to be carefully tested and migrated. We were working on a slower pace when it came to the versions actually being in use. So this is the versions as we went through compared to the official community versions as they were happening on the latest production that we actually ended. And merging these patches back and forth went between different versions. They had to be changed, adapted, since it was not always a trivial to just take a patch from the official version and pull it into ours, or taking our work and pushing it back, simply because we're evolving at a whole different pace on both sides. So the lessons that we took away from delivering by now, three shows using such a pipeline is adding other things costs us time. We needed to change Blender for introducing compatibility without outside tools, and the representing files that came from outside Blender, other assets, either need to be converted to a file format that Blender could read natively, or for some cases we actually had to build an actual render path so the renderer could read things directly. I believe we had an Alembic implementation that read extra features out of Alembic directly to the render engine and bypassed Blender intermediates. Also, when we were sending renders off to the farm, it required that we send a full blend scene and would actually load it into the full Blender, because there is a standalone cycles version, but it is more of a sort of research and development tool, but it is not a full featured renderer with a file format that would deliver all of its features. So in essence, we're always sending a full assembled scene with all the rigs and relative paths and dependencies, and of course a full animation to a render blade to render just one frame. And then that would need to evaluate all the rigs, all the dependencies that geometry actually has to end up to a full frame. And sometimes this could lead to problems that you actually send off a scene to the farm and some dependency in between was missing, and you would just end up with a scene that did not actually represent what you sent. It also slowed down the time to the first pixel, since there was a lot of processing going on before it actually started rendering. In addition, having the main application and the renderer being tied so closely together meant we could not just moving versions independently. We could not, since especially Cycles was adding a lot of interesting bug fixes all the time. We could not just move forward and update our versions, because the integration was tying it to a specific Blender version mode most of the time. And those were not necessarily trivial merges. So we had a few upgrades of the main Blender version during the production, but these were also sometimes tied to departments, sometimes tied to certain shots. And this was always a bit risky and were not something we would do easily. So for the next pipeline, our goal was that we could use Blender versions that are more closer to the upstream and that we could decouple the scene description from the workflows. That would actually have a scene description that is not tied to just as one application, and we would need to go in and out through this application to keep our assets. And in addition, separating the render engine from the scene description so that we can get faster rendering and sort of also more reliable rendering and lower overhead. At which point, after several discussions, we ended up building what is now being called Blackbird, which meant we moved to a more USD-centric pipeline overall. So the intermediate or the file format of choice, the representation was USD wherever possible. We wrote a custom exporter and I believe some importing code as well for Blender for handling USD files. And we could then just tie in Houdini and Maya and other applications, and they would all use the same USD file format. So that made it a lot easier to actually push changes back and forth, let departments use the application and version of their choice, and not having to update and change other departments. The render engine, we actually took the cycles source code independent of Blender and added a wrapper around it called HD cycles initially, which is a Hydra delegate. Hydra is part of USD. It is a common way of actually talking to render engines. So this meant we could use USD as an asset format and in addition as a file format to send scenes directly to the render engine. We then added a few specifics, render integration. The main one we wrote was for Houdini. So you could actually access pretty much all the features that we had in that new render engine in cycles and the few that we added ourselves. All of these features were now available to us in Houdini. And we could edit and change those, which meant departments could actually move in the middle of the work from Blender to Houdini if they chose so. This is a simple screenshot. This would be if I still had access to my workstation. I could give you a demo with maybe more elaborate content than what I have here right now. But basically, we could just take a scene out of Blender as it was. We could export the entire thing, load it into Houdini, and all the things that USD would translate for us would be there. We had a full scene graph. We had access to the shader nodes. There's all the lights. It all translated, and you could still continue working on it in Houdini. And this is a very simple scene that I'm showing here right now, but we put assets of actually full production size through this pipeline. So if you've seen NextGen or the soon to be coming, I believe it is now public knowledge that Maya and the 3 coming in Netflix was produced in-house. If you watch these shows, this is sort of the scene size, the complexity that this was built for and used with. Now, why would we choose cycles for this new render engine we're moving to? Well, first of all, it has already been proven in production. We delivered several shows using this, and we knew that what it could do. It has a wide hardware support. So far, we're mostly relying on the CPU rendering, but backends for other backends for other hardware were already in place, and it would not take a lot of work to enable those for us. It has plenty of features that we already needed. It has a lot of outside development that is very active. There's constantly new features added, bugs being fixed that we could just tap into, and it is getting a lot of support by now. We have all the major hardware vendors are contributing to Blender and to a certain degree also cycles directly with code, indirectly with sponsorship at the Blender Foundation. So this was something where we would not be working on ourselves on render engine, but we actually had active support from hardware vendors that we could even talk to directly if we needed to. We were already building on in-house experience for this. We had people that were really knowledgeable, that knew the engine inside out, that knew its limitations, that knew its strengths, and we had already a couple of features and fixes built in. And so we could leverage all the work that has been done already before. And as they call it, standing on the shoulders of giants. We could just start with a head start. We didn't have to build anything from the ground up. We could already take something and work from there on, not build from scratch. Now, if you haven't heard about Hydra is sort of a connection between scene graphs and render engines. So you have, on the one side, you have these Hydra scene delegates, as they're called, where an application such as Houdini or Katana can just implement the Hydra viewport. There's also USD view, which comes in USD directly. Omniverse out of NVIDIA, which to my knowledge is using it internally. So all of these use Hydra for their viewport for their drawing. And on the other side, any renderer that implements a Hydra delegate can be used inside these applications without actually having to change anything. So you could just write one integration once. You write something against the Hydra interface and you gain access either to all these applications or to all these render engines. And so there are already plenty of examples of render engines out there. So RenderMan has one, Arnold has one, Redshift, Radiant Pro Render, and quite a number more that are not in the slide. The current status that we had, well, I guess stuff last week, and the Blackbird that we had was based on the status of Blender and Cycles as a version 2.9.3. We had USD schema for shader graphs and settings, so you could actually have the shader graphs come out of, you could have them come out of Blender and translate them into Houdini, and you could just inside Houdini edit those shader graphs and nodes as you would do inside Blender. And the render engine would just readily display that, all the changes in the viewport. We added texture caching, which is sort of a must-have for production of that size, that just takes down the memory requirements when you throw tens of gigabytes, if not terabytes of textures at a scene. We took some of the patches that were sort of in development at the Blender Foundation and found that with some changes, we could actually use them in-house already, which were particle systems or / point rendering, which one of our engineers extended, light groups for better compositing. We added velocity and acceleration motion blur, which is a different way of representing motion blur that Houdini and USD are using. And USD scale instance attributes, polynomials. These are all sort of USD-ism features that were being used in a pipeline that Cycles did not have at the time. And this Blackbird render engine was in use by artists. So we had people in surfacing, lighting, and VFX using it every day inside Houdini. So it became an in-house tool. We got, of course, plenty of feedback. It did not start perfect out of the door. It was not by perfection as of last week, but it was something we could get work done. People could get work done. And if not, we were trying to, the engineering team was trying to fix and address those issues as quickly as we could. We had viewport rendering in Houdini, so people were using it interactively, just as you could use it on the render farm using Husk, Houdini's sort of standalone USD render engine, which did not require any changes from us at all. So both the viewport render and the Husk sort of offline render both go through the Hydra framework. So literally, it was only writing it once, and you could automatically get these two for free, in addition to USD view and others. And it was in continued active development based on what the day-to-day production needs were. So we had a roadmap of the features that we think we should be doing, that we need to do, but every now and then we had fresh things coming in from production that were urgent for a shot to be delivered, that then, of course, took priority. The roadmap that we had planned for, the things that were actually in development, we had somebody working in a new volume integrator. The existing Cycles render used ray marching, which is a well-established and functioning algorithm, but lately the industry has been moving to a different kind, to tracking integrators, and we had somebody working on building a whole new volume integrator for this. Adaptive subdivision was already prepared inside cycles, but it was not fleshed out, it was not finished, it had performance issues and memory issues, but we saw it was good enough to actually build a to finish it. And so we had somebody working on that. We were actively looking at many light sampling algorithms, deep OpenEXR for compositing. You actually get deep pixels, and there was a lot of pressure from the productions to bring open shading language into it, which would then solve a lot of whole other problems for us. So that was also being worked on. And of course, bug fixes, memory savings, performance, all these things were being built and added in development at Blackbird actively. And again, this was all driven by the needs of production. The wish list, the sort of things that we had on dreams that we could build eventually, was of course Cycles X, the new generation of the Cycles renderer that's being built at the Blender Foundation right now. We wanted to absolutely integrate that and build upon that. We were committed to contributing all the patches back to the Blender Foundation wherever we could, simply because in the previous work that we've done already, we found that this is the easiest way of keeping our code and the upstream community code in sync, is by getting all of our patches whenever they're possible and when they're usable, bring them back to the mainstream Blender, so that the difference between our code base and their code base would only be restricted to the absolute necessary. We also wanted to do a Blender build based on the core Blackbird. That is the fork of the actual center core Cycles engine without the Hydra part. Since there is no Hydra integration in Blender right now to speak of, I believe there are a few attempts at starting one, but nothing of the scale that we would need. Still, with these changes that we did to the core and having artists working in Blender, we just wanted to make sure that you actually get the exact same results and eventually just build on the same code base, both our Hydra version and a Blender version of the render engine. And besides Houdini, we've also planning to get more host applications to work with it. Since we had artists in the studio using Maya, that would have been sort of the next candidate to look at for a Hydra delegate, that we not just get the Hydra integration in, but also a more, well, first-class support. The additional things like node editing and all the custom parameters that are not USD standard, but extensions in the schema, that would have those in there as well. XPU support would basically just mean that we get support for using GPUs and CPUs simultaneously. I'm sure this is also on the Blender Foundation roadmap, but it's also something that we wanted to get. And Material X is, that is the emerging new standard for material representations. That would also be something very useful to actually have in there, just to make it more useful all around. Of course, I could go on. There's like my personal laundry list is as long of all the features that I had planned and that we wanted to get in there. Which, as of now, is yeah, really just a wish list. My motivation for going open source with this is, we went through this a couple of times, that we would be building this render engine anyway. One way or the other, we would be building it, and we would be open sourcing code, at least by pushing it back to the foundation. There would have not been any business case that we could have found that would have justified this turning into an actual full-blown commercial render engine. Since as soon as you do that, as soon as you charge money for your software, expectations come in. I've worked in commercial software for 15 years, and at that point, you're not just writing software. You have to support it, you have to sell it, you have to market it, you have to advertise it. It just adds a lot more overhead, and this is not something that Tangent was intending to go into. And just in speaking to other people, to hardware vendors, to studios, we just found that there was a huge interest in what we were building. This was not just us, other people also interested in having this. So open sourcing would have just been a benefit that we thought for everyone. Of course, this is not something that would come easily and for free. It takes more than just clicking public on a GitHub repo, since in order to get a successful open source project, there's some homework to be done. And that's not necessarily the homework that you do automatically when you build an in-house tool. So we need good documentation. The builds need to be very reliable, and for people on the outside to reproduce, you should not have to own a certain version of that certain operating system and that compiler and that machine and everything. It should be as easy to build as possible. You would need to have a test suite so people can test their patches. And there needs to be a process for actually dealing with code that comes from the outside or issues. So we have a process for merging PRs and for dealing with tickets. And of course, communication is key. The Academy Software Foundation has set up mailing lists for a whole number of its projects. And we would just need something like that also for such a project, in my opinion, to become really successful. We would need to have one central place of communication of everything that's going on in Blackbird. And the vision that we had, what we hoped to turn this into, was that this would be the present and future in-house render attention animation. We were committed to this. This is something that we were building for our needs, based on our needs, and something that we would hope to continue carry on future productions with it. And that this would be just one more option that people had outside of our studio as a render engine. And you could use this as an individual. You could use a render engine that you could play with that you knew that studios were using, or other studios of smaller size could easily also just use it and benefit from ours. Or if you had the resources to hire your own developers, you could continue working on it. And of course, we were then hoping on community contributions, also from certain hardware vendors we were talking to, and that this could also serve as an open source example for a full-size production render. Since if you look at the current open source landscape, there's you have all the tools and bits in places for building a really good render engine. You have Emry, you have Open Shading Language, Open Image.io, there's the file formats, there's Open VDB, Nano VDB. There's just a whole bunch of ingredients that are just there, and that pretty much anyone who's building a respectable render engine these days will use them in one way or the other. Not necessarily all of them, but these are just the bits and pieces that are there already out in the open source world that are very, very valuable. And the Cycles render engine was already using many of these bits, building upon them and turning them into a full-blown working render engine. But that one was conveniently and for better or worse wrapped up inside Blender. And it has many advantages having such a tight integration between the application and the render engine, but it also has limitations, and those were the ones we ran into. And this new other open source, well, fairly new open source project, USD, was then also there, just waiting to be integrated and to be added. This was the gateway that you could take that render engine and then just have an open source render for everyone that would just sit there together in between, encompassing all of these already bits and pieces that were there. In addition, we had hoped to actually publish production sites assets in USD format. We were sitting on mountains of assets that we could not publish because we didn't have the rights to. But our wish was that we could actually have a team of artists build realistic scenes, what the actual production challenges were that we had, built those into a scene, publish that as a USD under a liberal license so that people could use that to test the render engine, to do performance benchmarks, that researchers could actually test things with more than just a Cornell box and a Stanford bunny. Since that was always something that we felt has been lacking, that Walt Disney Animation made a great step forward by publishing some of their assets. But those assets are understandably in a special format just for those assets. But we thought actually having the kind of animation that we have, send out published in USD format would serve a very good purpose for everyone, that you could actually yeah, people could actually study it, look at it, how these things are built. They could test their, academics could test their new algorithms against it, or practitioners building and improving their own render engine could actually test it and see how it performs on a real full-size scene. And of course, for hardware vendors and reviewers, we found that the typical benchmarks that they use when benchmarking Blender sort of were already coming at the limits. They were sometimes reaching the limits of hardware in the opposite way, I should say. One of the Blender testings people commonly use is the BMW, which is 2 BMWs in a simple scene. And benchmark sites use that to just compare hardware against each other. But on today's hardware, that scene is already so small and tiny on a modern workstation CPU that actually fits into the on-CPU cache, which means if you're benchmarking it, you're not even benchmarking memory anymore, and you're especially not benchmarking storage. So this is a benchmark that is not a system benchmark anymore. It's a really tiny micro benchmark and not representative of anything that we would actually be doing. And by having such a scene out there, we could actually get benchmarks again that would, for the industry, for studios, tell a more realistic story of what that hardware was actually doing for them. So now to come just to the end is very abrupt. The end just happened first 2 days ago. And this is where the open source story becomes what we always talk about when talking about open source. That is, on my previous jobs, when my job ended, I sort of came out with empty hands. My work did not come with me. When a company goes under, when a studio dies, a lot of the in-house software just goes away with the studio. And that's always worked down the drain. And with open source, that's sort of a thing that's always been in the room when you're talking about publishing something as open source as this could survive whatever is financing this right now. And so this was actually somewhere in the back of our heads, is that everybody at the studio almost had experience of other studios that did not always end up the way they should be. And if we were to publish this as open source, this could actually go on and continue in the worst case. And I guess this is now where we get to see this play out live, where we hope that we build something that was not just for us of value, that for somebody else out there is of value, that this work will be picked up and continued. And I guess we'll find out if there's always, it's not just the software, it's not just the source code, it's also the people, the brains behind it that actually built the software that also bring value to the whole thing. And so who knows where the software will end up, where the people will end up. This is the address of the public GitHub repo where Tangent has been publishing all the source code that is public. Unfortunately, not all the puzzle pieces of Blackbird are public yet. I'm hoping we can get those to become public soon. I cannot make any promises. There's already enough in there to be useful. And yeah, I just hope that this is interesting to somebody. Somebody can make use of the work that we have done in the last couple of months and years. And so in the end, I can say thank you to a lot of people. The team that has worked on this was tremendous. The Blender Foundation that has built the render engine we were building upon, the hardware vendors that supported us, the USD mailing list, everyone. We can just say thank you to all these people that brought us this far. And I have no idea how long this email address will be functioning. But if you have any interest in talking about plans of how to continue this, I suggest you be real quick and email this email address. And so thank you for listening to my, unfortunately not so happy story. Thank you very much. So I don't know how this goes from here. Do we have a moderator?
Yes. Hi, Stefan.
Oh.
I'm just joining at the end. I'm not supposed to, but given the nature of your talk, I want to say that thank you for presenting with us. I think I speak with everyone who listened. Our heart goes with you and the team at Tangent. And we heard what you said about the projects. We'll be looking to see how the dust settles on the project, but we'll keep an eye on it. And please do keep us posted at the Academy Software Foundation about how the project is going as things clarify about Tangent and the next step with the technology. Thank you very much, and we're hoping we're with you on the open source side of things. We will see. We'll see to it if the community wants to keep the project going. We'll be there with you.
Okay, so do we have still time for a couple of answers to questions? I believe we have maybe 4 more minutes. Is that correct?
I think we can take a little bit of time.
So
we have a 15 minutes break between now and the next presentation.
Okay, in the Q&A I'm seeing, yeah, just starting somewhere. So is this the end of Blackbird? That is sort of the question that I have as well, that I don't have the answer to. The people that were working on it were excited about working on it, and they're sad that they cannot continue on this, at least as it stands now. If somebody can help us continue this, we would be really, really happy. Is the Blender Foundation interested in making the Hydra backend to merge this back into Blender cycles? The actual changes to the cycles core, I've heard some of the engineers talking about just pushing those back to Blender cycles on their own time. If you have ever worked in this area, I believe I had the experience that actually publishing changes like that is a good thing on your resume. It actually is very visible if you do these things. If the Blender Foundation is interested in maintaining the Hydra backend, that I have no idea. I don't know. We certainly, a part of the reason why we made this a so-called friendly fork and renamed this is that we did not expect the Blender Foundation to maintain Houdini plugin or Maya plugin. That is just not their business. It is not what they do. It is not what the foundation money is intended for. So that we thought was our part to do, to actually make those tie-ins to closed source software, since that is not the place of the foundation, I think. Are all those elements of Blackbird Pipeline being open sourced? I hope so. There's parts of it are being open sourced. I believe the important parts of it are missing still, and I hope that they can actually be put into public repositories real soon. Does Blackbird support ray tracing? Yes, it does. It's built upon ray tracing and path tracing. And how big of a scene can you render out in 3D? If you watch on Netflix, if you watch Next Gen, or if you watch the soon to become hopefully Maya into 3, that is how far we went. That is what we could get out of this. So is this, yeah, this one I answered just quickly. Has any of rendering research touched on the grease pencil features? No, the part that I worked on was pretty much exclusively to the Cycles render engine. Will Tangent's final show still be released when Maya into 3 is supposed to be released? I have no date. This is all in Netflix hand from there on. What kind of steps are you guys taking to reduce the time for first pixel for Blackbird? A big one we found is the tangent space calculation. People were using normal maps, and there's a really inefficient piece of code to calculate tangent spaces inside Cycles and Blender. If you throw a multi-million polygon mesh at it and render it once with and without a normal map, you will see immediately what I'm talking about. There's a problem. I found the solution pretty much this week. I hope that I still can get it published somehow and test it and finalize and whatnot. This is one of the steps that we found. Texture caching also brought a huge benefit, since we didn't have to load tens of gigs of textures into a machine's memory before we could actually render a single pixel. Texture caching would just load the actual pixels that were needed on demand. Is there a reverse recruiting list for the tangent talent? Yes, there is. An unofficial one that I know is being compiled by people there. I don't really have a direct pointer where you find, oh, actually, yes, there is somebody. An answer came in, thank you, please. Any plans to open source architecture decisions behind Blackbird? That's an interesting one. If I'd be happy to, if I can make it at all, if there's a way, talk in depth about this at the Blender conference next year, which I hope is going to happen again in person. I'm looking forward to it. It's one of my favorite events. And this is, I believe, everything that I'm seeing. Is the question, tangent open source GitHub, will it continue or will it disappear in the future? I don't know. I guess it's an, I don't know if it is paid for, if there's somebody gonna turn it off once the build stops getting paid, or that I don't know. The answer somebody wrote is fork it now. Yes, if you have interest in the code, it's open source, it's there, fork it and use it. I believe everybody who has worked on this will be thrilled to know that somebody else found this useful, the work that we did. So that concludes the questions that I saw in my Q&A window.
Thank you very much, Stefan, for being with us today. It was a great presentation.
Thank you for having me.
Okay. Thank you.
Right. Have a good day.